Hello, and welcome to a delightful and possibly bizarre Sudoku puzzle. This is the Cube by Marvin Kannhauser, and I clicked on this one actually originally thinking think lines were going to be German whisper lines, and was very curious about how they were going to set that up. As it turns out, that's not the case. Instead, we've got a whole mix of rules that all seem to employ some interesting math, and so I figured I would have to go at it and film myself. And if it works, great. I might see if I can get permissions from the powers that be and get it posted. And if not, then it'll be an interesting thing for me to look back through and potentially talk through with some of my students. Now let's take a look. So this one says normal Sudoku rules apply. The digits in the white circles must appear in one of the four cells touching these circles. For example, if I'm looking at this circle that says 239, there must be a 2, a 3, and a 9 somewhere in here. It says must appear in one of the four cells. I'm going to take that literally as opposed to at least one, even though technically I guess I could get the same digit in cross corners on some of them. But we'll see if multiples is an option. All right. Additionally, every edge of the cube sums to the same two-digit number, and this number is given in the grid by the three two-cell cages, all of which are filled identically with the tens digit at the top, is the top number, and the units given below that. There. I totally skipped one. We'll come back to it in a moment. But basically, these five, so along this pink line here, and these three must sum to the same number, and that number is given here with the tens digit here and the ones digit here. So if this were, for example, 23, this would also be 23, this would also be 23, and that would be the number that these would sum to. That is an option, and we'll look through it in a bit. And the last one that I totally missed the first time around, it says the digit in the gray cell must be higher than its four orthogonal neighbors. So this one here must be high enough that all four of these are lower than it. And technically you can have a repeat here, but take a look at that in a bit. Cool. So I'm gonna go ahead and jump into this. I've gone ahead and provided the link below, say it in advance because that's what I know to do by now. So that if you're seeing this and curious about checking it out yourself, you can go ahead and do that. I know I did, and that's where I am. But yeah, let's dive in and see what's going on. All right, first off, I'm gonna go through a little bit of limitations here because I know that these are all my tens and I wanna figure out my range of these lines. If this was as low as I could possibly get it along these five, I know that none of these can repeat. And so if I were doing 1, 2, 3, 4, 5 in any order, that would be 15. And that is the lowest that I can go, even though among these three, I could go lower. Similarly, on these three, I want to figure out the highest that I can go. And I guess in theory, we could say 7, 8, 9, and 7, 8, 9 sums up to 24, with one slight caveat that we could technically go a little bit higher in a weird way. And let me just map this out. So like, for example, if we were doing a 9 up here and these ones were 8s, we can technically do that legally because these are corners. And then I could repeat that same amount by putting a 7 here and putting 9s here. Legal, bizarre, but still technically works for the purposes of the puzzle. And then on this end, I could once again go 9, 8, 8. This is probably not the case, but that gives me my ranges. I know that whatever I put along those lines is going to sum up to something in between 15 and 26. So that means that all three of these, which all have the same value, are either going to be 1 or 2 for my 10s or 20s, and they're going to be between 15 and 26. I am also seeing something convenient might come up later. The cells here must have a 2, that's possible. The cells here must have a 2, that is also possible. And as long as we're at it, I'm gonna look down this row because this one is telling me that I only have 2 cells left in here to fill in that same 1 or 2, because this space here sees across these, this cell up here sees down here, this cell here sees down here, and so I've got just these 2 left. And whatever it is going to match this. And, oh, I just wrote 2 and 3. I got ahead of myself there. Okay. And it's because I was looking at this and seeing 1, 2, and 3. but that's a little bit promising to start with because I've got the 1s and 2s as options when starting this puzzle. Okay. All right, here, just for grins. So I know that this one can be as high as 9, and I'm just going to kind of work my way down. Now, technically, I could make it 3 if all I'm worrying about is, like, for example, these two being 1s and these being 2, and oh, spoke too soon. I can make this one 4. And have 1, 2, 3, and do like that. And technically that works. I do have the potential of this and this getting in the way. But I'm going to ignore that for the moment. The other thing I'm going to try to sort out is I'm going to look for the ones that are the most common in these circles. And I'm seeing 1, 2, 3, 4, 5, 6, 7 sevens. Right? 1, 2, 3, 4, 5, 6, 7. All right, so that's a lot of sevens. And in theory, any number of them could be shared. It says the digits in the white square must appear in one of the 4 cells in such a circle. It doesn't say at least, so I'm going to try to take that literally, and I'll see if I need to revise that. And I'm actually just going to see if I can eliminate any of them as we go through. So, oh, here's something fun. These ones all have a cluster of 7s set up, and they could, for example, have like a single one here that would count for all of these. However, if we separated them, put it down here that shares a 7, but bear with me, then I could go that there, and then this one would have to be up here, for example, which still shares with this. Vice versa, if I put this here and this here, then this one would have to be up here to share with that. All right. Which would actually break this one. Because if I put this here, then I wouldn't be able to put anything around the 5, 7 set. So I'm going to this one, not 7, that one's not an option. Intriguing. I'm going to color code these like crazy right now. I'm going to uncolor code them later. So this one can't be a 7. And I'm just going to start my way up top and work my way down. Okay. So if I make this a 7, that cuts off these ones down here, cuts off the rest of box 2. So that means that this cell could be a 7. It's the only one that satisfies these two. That works. And then that would mean this one goes down here. That works. I'd need one in one of these 2 boxes, and that makes the puzzle. So this one, once again, not a 7. All right. Checking in on this one. Okay, if I set up that one there, then I've actually got some options. So once again, this set is out, but I need one of these 2. Let me see where I go from there. If I put it here and here, then that one would have to be a 7. And one of these 2 would have to be a 7, which still works. These ones would have to share on exactly that one. And this one has been cut off. So the one on the edge here, I can't put it in either of these ones. So I can't make this a 7. If this one's a 7, can I make this one a 7 period? 7, 7. No, it looks like I'm going to run into the same issue that I did before because I will have these ones boxed off. How interesting. Okay. So this one can't be a 7. This is amusing little logic as I go through. All right, so I've got seven, 7, and then that can be any of these really. So tackle that one there. One of these 2, and then one of these 2, which cuts off that. That is doable. Aha, cool. We've got an option for 7s along those lines, and my way around still. Is it the same if I do it here? I think that's the same setup. Yep, that is the same setup if I do that one. If I do it here, what does that change? Right, I'm going to put that one there. That means that I need something for this set down here. And so it would be this one, which comes with that. Still one of these two, and can't be one of these two. That breaks the puzzle. How funny. Okay. So that one can't be a 7. And just like that, the start of a domino. Not brilliant, but it is a thing, and that might make sense there. Find out in a bit. To make this one a 7, one of these two is still a 7. That cuts these ones off, so it's one of these two. And that doesn't work because I would need this one and this one to be a 7. So this can't be a 7. What a funny thing. Cool. If this one is a 7, that cuts off these two. So this one must be still one of those two. Can't be here though, so I can't make this thing 7 either. Right, because if I put this here, I still need one to touch this 4-7 set, and there's already something here, so I can't put it in either of these. So that is also a not 7. So many options, so little time. So I feel like I've definitively proven, just by going through them, that if they can only appear once per circle, this one has to be a 7. Because if I put something, if the only one that can go around this is this single 7 here, along with that one as a definite 7. And the rest of these just kind of, they fall into place in partial dominoes, but I call good enough for the moment. All right, I'm gonna take a look at, I'm gonna look at 2s. And while I'm at it, I'm gonna clear the color on this because I don't need them anymore. All right, looking at the 2s. Oh, the 2s are interesting because I've got these, and we really should have started on 2s. And what do I have in 2s? Oh, I just found something really cool. Okay. So these, because I've got 3 of them, I need in some way for 2s to appear once along row 5 and once along row 4, right? Because that's just Sudoku rules. But if I put, for example, a 2 here and a 2 here, 2 can't go anywhere along this set, so I'm minus a 2. Same thing if I go here and here. So 2 must be along this domino, and that means that this is a 2, which means that one of these two is a 2, and I think it's going to be that top one right there. Just because of where I'm at. Take a look and see what other things I can eliminate from that. So this is a 2. What other 2s does it see? So it's one of these 2 up here. Sees that, which means that's one of those 2 there, which, oh, would eliminate these 2. And then one of that was exactly that corner must be a 2. So this is a 2. This one can't be a 7 anymore because it can't be up to 27. We've already proven that the 26, the literal highest it can go along the lines is a sum. So those need to become 2s, and that means that these also each become 2s. So this, one of these 2, is definitely a 2. I guess possibly the other one is a 1, but I'm sticking with the 2s for now. And that gives me something else that's pretty nice. That means that one of these is a 2 along this line because of this and this, which see rows 4 and 5. And then looking up the same way, columns 4 and 6 are occupied by 2s, which means the only ones left for 2s are going to be these 2 here. Correction, they've got this 1 because of these little things here. That one right on top is a 2. So I got 2s in a lot of places, and very conveniently helping me work through the puzzle. Oh, further development, this one can't have a 2 here, here, or here. Has to be this one as a 2. Theory was sound. I just need to follow it through. Cool. Okay. And that means that along here, I got a string of 2s. which I can leave there for the moment, even though it's not super helpful. But, ooh, I've got some information. I've got a 7 and a 2. So even if these are as low as they possibly can go, if they're a 1, 3, and 4, 7 plus 2 is 9, and 1, 3, and 4 is under 8, so it could be 17. But I know that it has to be at least 20, so I'm not going as low as I can go. And same along here, 7 plus something else that needs to be above 20 and less than or equal to 26. So I still have that option of double mining this in a way that I don't like, but you know, it's an option. Cool. Let me see what else I can fill in. One of these two is a 5. Okay. If this is 25, then that's going to make a difference. Got the 2 and the 7 accounted for here. That means that one of these ones is a 4, which means that either it's the shared 4 or it's this up here. And then this way. Let me see what else I can knock out. Some of the other common ones. I'm seeing some 3s, and I'm seeing a couple of 1s, not enough to really, you know, stake any solid on. And a couple of 8s, but I don't feel like I've got information on those yet. All right. This one is a 2. Up here, as it is possible to go 1, 1, and then I've already got 2 here, so 3 and 4. So this one, now we've moved it up, can be as low as 5. That's not very practical. I'll come back to it later. It also can't be 7 because of this domino. Let me check out the 3s. Okay. So 3s have to be one of those ones, one of these ones, one of these ones with the overlap again, one of these ones, and one of these ones. So I've got some opportunities for overlap and elimination. I'm just going to go with the one that gives me the most information for starters. If I play one there, then one of those two would need to be a 3. That would go up this way. One of these two would need to be a 3. And then for this one, really any of these could still be a 3, and puzzle would work. So that is an option. Right, are there any I can eliminate? Put one here, for example. I can't put one here along with that. I could put it here. Nope, I can't. That would cut off this. So if I put something here, that would cut off both of these for the same reason as before. So 3 can't be there. That is a non-3 option. Can a 3 be here? 3 can be there. We just proved that one. Can a 3 be here? I think so. So I can go 3, 3, 3, 3, and 3, for example. Doable. Can I make anything else happen on here? Let's see, this one, stuff. This one doesn't want to make a difference. Okay. Well, the 3s aren't as productive as I might have wanted them to be. That was okay. All right, the 7 and 2. The only thing I know on diagonal is one of these 7s. If I were going 7, let me see if I can eliminate the 25, because if I can, that becomes a 5. In order to do a 25 on this, I would have to be weird. Can I do a 25 with 7 now? Hang on. Okay, so 7 plus 9 is 16, and plus another 9, so I'd go 9, 9, 7. Okay. And then 9. I don't think I can do that. No, okay. If I go 9, 9, 7, 9 there, and then I put 9 here, The highest I can get to, I can do 9, 8, 8. Oh, I can still mess around with 7 sometimes, but no, it doesn't make a difference. If I do 9, 8, 7, right, 9, 8, 7 is 24. Okay. 9, 8, 8, technically works. 9, 8, 8, 7, 9, 9, 9, 8, 8. Wow. That would be bizarre. That's the only way to get to a 25. I don't think that's likely. I really don't. Is there any way to eliminate that, though? I don't see it right now. Not off the top of my head. So we'll see what else I can drum up. I'm liking this idea of like the one overlapped cell between things that share numbers. It didn't happen here, but other place where it seems like it's doable. One could be a 4. We've got 3, 4, 8 right along here. Possibility of a 2. Oh, it can't be 25. Here's why. This is bizarre. 7, 9, 9. Okay. And then 9, 8, 8. Here's why. These 8s block this 8 from existing around this cluster. And these 9s, 9 here, and then 9 along the 7s, block this 9 from existing. That would break the puzzle. This could not be 25, it's 24 lower. Well, thanks for that. So that goes away. That means that this one is definitely 5. And maybe that doesn't give me great information, but it's information. So, you know, you do what you can. So this thing is accounted for other than whatever's in this blob, and it's going to be less than 5, which means that all of these ones are now designed to 1, 2, 3, 4 as options, and that's very cool. So I've got a 5 here, along with a 7, 2, which means that the combinations of these ones have to be the same thing, which is doable if they're the same numbers. So I've got 14 in there so far, with 5, 7, and 2. And if I want to go to 21, then I need this to be a combination that makes 7. If I want this to go to 24, I need this to be a combination which makes 10, both of which are totally doable. Yeah. Are there any combinations that are not doable? That becomes the next question. So you do a 6 and 4 along here. Do 10. And oh, here's something funny. So if I did that, I have to go 6 and then 4. I mean, sorry, vice versa. I can go 4 and then 6, because then I'll make this 24, and then need a 4 right here. And a 4 right here. Actually, just for grins, I'm going to remind myself that these are all the same digits. They're all the same color. And also for grins, I'm going to remind myself that this one is also green. How fun. So whatever it is down here, oh, that helps. It's actually along the lines of what I was just saying. So if this wants to get to 24, then I go 5, 7, 6, 4, for example. Okay. So here's what's awesome. This has to be 20 something. The something number is this number. Why? Because this thing sees this thing sees this one sees down here, all that's left is this one. That means that whatever this number is, 1, 2, 3, 4, is what's achieved when I make this a 6. Because 5, 7, 6, 2 gives me exactly 20. Whatever I add finishes it off. That is an interesting way of setting that up. And that gives me one more thing that I can break down. I see 1, 3, 6 over here. That means these two are possible sixes. Given that I've got a 7, 2, and I might be dealing with the same stretches of digits, the idea of this being a 6 feels very viable. Okay. And I've got a 1, 2, 3, and 4, which obviously is not a 2 based on these ones being 2s. Given the presence of 4s, for example, if I have a 4 here and a 4 here, that means that these ones can't be 4s. If 4 is here, that technically still works. These ones, one of those ones is a 4. What else would not be a 4? I don't have a lot of 4s given in the circles, so that doesn't really help. But if this is a 4, then this one has to be a 4. That stands to reason. If it's a 3, can I do anything about that? Because I saw some 3s earlier. And if it's a 1, I'm going to check out 1s as well. So if it's a 3, let's say this is a 3, and this is a 3, and this is a 3, and this is a 3. That means that satisfies the 1, 2, 3 here, which is kind of nice. That breaks this, because this has one of these two has to be a 3. So none of these ones is a 3. Bing. So it's either 21 or 24. How funny that it's, the first two that I said has to be between 21 and 24, and hey, it's 21 or 24. Let's check out 1 and see if 1 breaks it, and I kind of hope that it does, just because of where we are. So 21, that doesn't matter. This one's already accounted for. These ones are seen, so the 1 has to be exactly this one here. I don't know, not because that's what's the one on the bottom. The 1 has to be one of these two. Has to be outside of this grid, has to be outside of this grid. Could be one of these two, and if so, that knocks out that one. Are there any other ones that I'm missing? I'm not seeing any other ones. So technically still doable. All right, trying it with 4s. All right, all of the greenish highlighted ones are 4s. That means that this one must be a 4. One of these two must be a 4. Okay. Okay. Checking along this line. If I want 5 and 2 numbers to make 24, oh, can I even do that? No, I can't. 5, So 5, 9, and 9, 18, 23, I can't. So this one has to be 21. Yeah, so 5 plus 9 plus 9. 9 plus 9 is 18 plus 5 is 23. That wouldn't work. I can't get high enough for that when there's a 5 in the corner. So these ones all have to be 1s. Excellent. And that opens up the game a lot more. So one of those two is a 3. With the 1s on hand, that means that I think I already proved it. That one was a 1, yes. Okay. And it means that one of these two is a 1. And what else am I eliminating along the way? One of these 3 is a 1. This one. Oh, no, this one must be a 1. It's this corner right here. Why? Because this box 5 can only have 1 in one place. All the rest of them are eliminated. That becomes a 1. Intriguing. Okay. So 5, 7, 6, 2, 1 altogether equals 21. 21 is the number that I'm adding up to. 7 plus something plus something equals 21. 5 plus something plus something more restricted equals 21. I've got 7 here. And I need to get a combination of 7 in between. 6 and 1 was doable earlier, but it's not anymore because I've got this 1. 5 and 2 is eliminated. 4 and 3 is my only option, which means that one has to be a 4, and this one has to be a 3, right? Yeah, that's correct. And cool. Eliminate some more stuff. So in the green one, I've got a nice whopping 10 there. I need to get to 11, so I could do that with a 3 and an 8. I could also do that with a 6 and a 5. No, I couldn't do it. 65. I need a 3, 7, 8 around here. So 3 and 8 is totally doable. 3 and an 8 is doable. 7 plus what? 7 plus 4 could get me there. I'm tempted to just plug in the 3 and the 8 because I've already got a 3 as an option on this one, but 7 and 4 is also doable. So 3, 4, 7, 8 without a 3 on that one, and without an 8 on that one. Mm-hmm. 4 and 7 is doable, and then I need my 3 and 8 here. Why did I put the 3s and 7s on this side? Oh, because that 7 is blocked down this. Yeah, and okay, it has to be 3 and an 8 back to instincts. 3 and 8, these ones are not 3s. These two are 7s, and this one's whatever it wants to be. 3 and 8 is 11, and that satisfies that. And let's check on the next one. 8, 2, and 1. 8 plus 2 plus 1 is 11. I need 10 left here. I've got a 7 and a 3. Well, gee, that's convenient. Do I want to look at gift horse in the mouth? I really do. Maybe I shouldn't, but I want to. I need a 3 in one of these two places. So if I do it any differently, if I put a 3 here and a 7 here, no, I can't put a 3 there. I have to put the 3 down here. Back to what I'm hoping will happen. Oh, so this maps out very nicely. Okay, so I've got my 1, 2, 3 satisfied. I've got my 3, 7, 8 satisfied. I've got my 1, 3, almost 6 satisfied. 6 is satisfied. Be down to 6 right there. 8 and 6 together is 14. This one needs to be a 7. Can't possibly be anything else. Yep. And one of these two is still a 7. I guess that doesn't matter quite as much now. It's a very interesting puzzle. I feel like I keep looking at combinations of 7. Maybe it's just because I'm seeing 21 as, you know, an average of 7 times 3 over and over again in little clusters that make 7s. But that's cool. Okay. 5 and 7. One of these ones needs to be a 5. And this one here is no longer 7. I've still got my 2 options either here or here, and that doesn't change the puzzle at all. 1, 2, and 8. I've got my 2 possibilities. I've got my 1 possibilities. My 8 possibilities probably are going to go along this line just because of how hard they're going. Or 7, 8, 6 is also an option. Okay, this is an 8. This is an 8 that covers both of these circles. And nothing else that I can eliminate. Okay, I'm going to dig back into the center one. So I'm digging into box 5. Why? Because, well, I've got most of it filled in, and a nice little caveat for this that can probably take it the rest of the way there. 2, 4, and 7 is already satisfied here. So I just need to look at the numbers that are missing. I am missing 5 and up with the exception of 7. So 5, 6, 8, 9. This one can't be 8 or 9. This one can't be 8 or 9. Because if, oh, so it still could be 8, I guess. I don't like it there, but you know, either of these could be 8. This one could just be 9. Neither of these ones is 6. One of these two is 6. Good. Next steps. Oof. All right. Oh, I've got 6, 7, 8 that all see this one. Does that make a difference? It doesn't really, unfortunately. This one's seen by a lot of stuff. And so it's got a limited number of options, but not as limited as I would like. So this one can either be a 4 or a 5. Can't break it down to just one, but it can't be 1, 2, 3, 6, 7, or 8, or a 9 in here. So it could be 4 or 5. This one could still be 5 based on the one on the bottom, but it can't be 5 up here. If I do 5 and 6, this one could be an 8 or a 9. That's doable. And let me see what this one sees. This one sees 1, 2, 3, 6, 7. 1, 2, 3, 6, 7. All right, so it can be a 4, can't be a 5, or an 8. So I don't think this is going to be an 8. If it is, this one's definitely a 9. That's kind of a funny thing when you put it out that way. All right, sweet. All right, back to here. This one with my 5 in the corner, which is probably going to be one of the most restricted ones that I can do here. 5 plus 16 is equal to 21, which means this either has to be a 9 and 7 or an 8 and 8. 9 and 7 or an 8 and 8. I don't think it can be an 8 or 8. And let me just check this out for a moment. So if this is 8 and 8, then it means that this one must be a 4. Okay, because it can't be an 8 anymore. I guess it doesn't change anything to this one down here. Can't be an 8, this one must be a 9, so it forces it into a 9. Ah, it's technically doable. All right, well, let's mark them up then. So these ones can be 7, 8, and 9. Okay. So yeah, I'm going to come back to these in a little bit because I have a feeling that there's something going on there that I just didn't see the first time around. Okay. All right, I should probably take a step back from trying to solve these particular clues and see what I've got in the way of Sudoku because I can use those rules as well. Oh, I misspoke. This I can break down by 3s and 4s. Not 4s, 3s and 8s. And that means that this one must be, so the 4s must be among these two. This one can't be a 2 any longer. Why? Because I've got a 3, 8 pair. They're both in these two. That's a 3, 8 pair. That will make a difference when I get these ones with more information, but that also means that the 2 can only be here. And that starts narrowing down my 2s. Nope, it just gives me a little bit more. I've still got these 4 sitting here on these 2s. But okay, let's check out the 1, 2, and the 8. So if an 8 is here, an 8 can't be here. Could an 8 be here? If an 8 is here, that is technically an option. Kind of annoying, but it's an option. Because I can put an 8 here and an 8 here, which would turn these into 7 and 9, respectively, along this line. And doesn't break the puzzle anywhere else that I can see. So I think I'm good there. All right, gonna look at one of the other things that's close-ish to full. I've got 2 things in boxes 8 and box 6 that are pretty close. I'm gonna check out box 8 because it sees a lot of stuff. Mostly these ones here, 1, 2, 7, which are the same ones still in the box. It's the same thing here, true here. This one sees 3, 4. Oh, not exactly the same here. We've got a 6 and a 1 here. Okay, so if I'm looking at row 5, I know that I'm looking for a 1, 6, 8, 9. So 1, 6, 8, 9. This one can only possibly be 8 or 9. So the rest of them are counted for, and I've got the 1 and 6 right here. Is there anything else I can eliminate? This one can't be 6. One of these two has to be a 6. Just to go along this row. And I can't narrow down anything about a 9. Weirdly, I haven't placed a single 9 yet in this puzzle. I wonder if it's going to be this one, and that's going to be something that gives a lot of info once I get there. There are no 9s representing any of these circles, which means that these places that see multiple spots along this cube, not 9s, at least not so far. Okay. All right, 7. This one can't be a 3. I'm trying to get to 21. 7 plus 3 is 10. I can't put an 11 in here. This one has to be an 8. That makes life a little bit easier. That's an 8. That's a 3. which means that this one's a 6. So kind of like this one, just a little bit in reverse. If this one is an 8, that takes away the possibility of these being an 8-8 set. So these can be 7 and 9, which still doesn't break anything yet, but I think this is going to be 7, and this is going to be the 9 just because of this one. And I'll find out when I get closer to. All right. 6, 2. One of these two needs to be a 1. This one has to be a 6, as per what I've included on the row earlier. One of these two is a 6. I already knew that. And oh, one of these two is a 6, which means that one of these ones is a 6. Even though a 6 isn't mentioned in any of these numbers, most of them are already filled in. We've got 4, 7 here. I've got the 2, 3, most likely 9 here. I've got the 3, 8, and one of these two is a 4, and 1 and 7 here. So one of these ones is a 6. It's not yet spoken for. Similar to the 9s, and I'm going to check in on the 9s in a bit. All right. 6, 2, 7 is 15. Not a lot left to go in the combination that makes 6. I can do it in 5 and 1. Is that the only combination? Oh yeah, because I can't use it in the 8 or 9, which are also involved in this row, because that makes it too high. 6, 2, and 7 adds up to 15. 15 plus 6 is 21. So this one, the only one left is a 1. I can't be an 8 or a 9. And that one must be a 5. Taking away the 5 there, clearing out some pencil marks, so that's nice. This I can get rid of the 5s here. That means that this one can be a 5 here. That's good. So I need a 5, a 6, an 8, and a 9. This one could technically be a 9. 6, right, 9. Okay. That's good. That's good progress. 6, 3, and 1. This is 10. I'm going to need 11 more. I can do this in 7 and 4, which are already set up nicely there, and I appreciate that. And so once again, I kind of want to go with that. 7 and 4 makes 11. This 9 goes into play. I like it, and I think that's going to turn out to be the case. I just can't prove it for certain yet. Okay. And let me see if there's anything else that I can eliminate now that I've filled in some portions of cubes. This one's counted for. This circle is counted for. This 5 and 7 is counted for. I've got almost all the circles, excluding this. I need my 7s in one of those two places. I haven't been able to eliminate them yet. Okay, if I go 7 and then 9, I'd have to put a 2. Oh, that's easy because that's the same box. So even though, and also 2 over here, I just need to look at that one. Okay, so yes, this is a 7, that's a 9, that's a 4. Why? Because I can't do 9 and 2 here because there's a 2 here and a 2 here, just as long as we're at it. And that would break the puzzle. And that is the entire cube. The rest of this is just Sudoku, excluding this piece right here, because all of these sets of circles are covered. And all of the lines along the cube are covered, and all of these boxes are covered. Nice. All right, that took me maybe a little bit longer than it should have, but I'm in the right direction, and I can figure out the rest of it from here. So I'm going to take a look at some of the rows that are closest to finished and see where they're at. So I've got 1, 2, missing a 3, so there's a 3 somewhere along the top here. One of these two. 4, 4 on the top or along the bottom. One of these ones. 1, 2, 3, 4, 5, 6, 7. I'm missing an 8 and a 9. 8 and a 9, of course. 9 can't be in any ones up here, so that means that that is a 9, just by some process of elimination. 9 is one of these 3 along here. I've got a 3, 4, and then whatever's in the middle that I'm missing, that is my 8. 3, 4. 1, 2, 3, 4. I need a 5, which I don't block off yet. How unfortunate. And a 9 once again. That makes sense. We were missing 9s for almost the full puzzle, and now we're getting those ones plugged in. That 5, does that see anything else that needs to be seen? Not yet. Then I'm popping that row in there of 5s. But hey, I've got this complete row. Let's see what I can build in that. These ones here don't see quite as much as I might like them to. Sixes in one of these two. 1, 2, 3. I need a 5. Once again, I need a 5, and once again, I need a 9. Oh, 9 has to be in the top up here. Because 9, 9, and 9. That's nice. So 6, and I need a 5. Not seeing that narrowed down yet, but oh well. So that means that 5s, I've got 5s in one of these two. All right. Looking up this way, I've got 5s in one of these 3. Not as good, but all right. All right. Let me see. I've got 3s, 4s there already accounted for. And all right, I'm going to try the other sides of the cubes and see if I can figure out where my other 9s go. One of these two is a 9. That makes things nice because this one can't be a 9. It means that this has to be a 9. Looking my way up, this can't be a 9. Okay, finally, this one is a 9. I was hoping that I would find some easy way to prove that earlier, but I guess I just had to do the long way around. There's probably a shortcut that the experts figured out that I just didn't. These are a 6, 8 pair, which is kind of nice. So I've got 1, 2, I'm missing 9 possibility. I'm missing a 9 possibility. So one of these two is 9 in this row. I'm also missing a 3, which is weird. Figured I wouldn't be missing 3s. One of those two is a 3. And what's my last one out? A 4. Okay. And drat, any of these can be a 4. So I got 3, 4, 9 possibilities going in there. This is 4, 8. That is totally doable. And all right, let me see what else can narrow down. I've got 1, 2, 3, 4, 5, 7 along this row. 3 is out there. 8 is out there. 6 takes that, and doesn't really make a difference. So 8 and 3 in this pair. Okay. Can't be a 9, so this one must be a 9 because can't put 9 else there. Nice. 3, 8 pair. 1, 2, no, 3. That one's going to be a 4. That one's going to be a 3. That one's a 4. But 6 is left over up there. 6s and what else are you? 6 and 7s. All right. 6s and 7s. Up over there, we've got 6. I've got a 7. 6s down there, 7s in this corner. Which means one of these two is 7. This one's a 7. That blocks off the 2s. That one's a 2. That one's a 2. 5, 6, 8, 4, 9, so on and so forth. These are still an 8, 9 set. Nope, they're not. That's a 9. That's an 8. 4, that's a 4. This one could still be a 4 or 5. Weirdly enough. This one has to be a 9, because that's all that's left there. 1, 2, 3. I don't have a 3 in this box yet. So I break anything that does not. 1, 2, 3, 4, 5, 6, 7, 8, 9. Putting the 8 in there. 3, 4, 4, 9. 9's up here. Can this one still be a 3? It can't. This one must be a 4. This one must be a 3. Got a 6 and 8 going on here. What am I missing? I'm missing a 1 and not a 9 for this. It's a 5. So I'm missing a 1 and a 5. Okay, it's 1 and 5. 1, 2, 3, 4, 5, 6, 7. This is the only option for an 8 in this row. All right, in this set, I'm missing a 5, or a 5, a 6, and a 3, which is blocked from here to here. So that one's a 3, that's a 5, 6 pair. And that can narrow it down. All right. So in this one, I'm missing a 4. Can't place it here, can't place it here. I have to place the 4 here. That means that this one's my 5. And this one's my 6. This one's my 8. That cleans some things out. This is a 6. This is a 5. 5 eliminated there. One of those two still. 6 and 8. All right, this should solve pretty fast by now. It's just filling in the blanks. 2, 4, 5. This is my last 6 in that one. Putting this one as a 6 over here, which means that's a 5. 1, 2, 4. I need the 4 to be over here. I'm looking for a 7 and an 8. Do I have any ways of eliminating those? I don't yet, but 7s forces that to be a 6, forces that to be a 7. Oh wait, no, I did have a 7. I have a 7 down here. So this is an 8. This is a 7. So that's an 8. That's a 3. That's an 8. That's still a 1, which the pencil marked a while ago. 5, 1, 5. And looking around to see if I missed anything. The final one should be a 4, and that covers that. All right. Wonderful. Well, thank you everyone for watching. Hopefully you enjoyed the solve through and didn't tear your hair out when waiting for me to notice things that I should have noticed earlier. Yeah, this was an excellent amount of fun, and I seriously appreciate the puzzle maker and the Cracking Cryptic crew. Excellent. Thank you all. Have a good day.